right. Hello, everyone, and welcome to our informational webinar about the second Space Resources Challenge we recently launched in October. My name is Ryan Jack Mahone. I'm a national trainee from Luxembourg working on space resources applications and coordinating the different activities for the second Space Resources Challenge, and I'll be your moderator today as well as presenter. Thank you all for taking the time, and also best wishes for 2025. Joining me, we'll have Kathryn Hadler, Director of ESRIC, the European Space Resources Innovation Center in Luxembourg, Bob Lamboray, Senior Advisor at the Luxembourg Space Agency, Andy Gray, CEO of Exotopic, and Melchiorre Conti, Space Resources Engineer at ESA. Before we move on to the agenda, we'll give the participants of this webinar to give a few words to introduce themselves. So, Kathryn, if you want to start.
Thanks very much, Ryan. Hello, everyone. My name is Kathryn Hadler, as Ryan's already said, and I'm very excited to be able to present this challenge to you today, the ESA and LSA challenge. In ESRIC, we're a research innovation centre entirely dedicated to space resources. We worked with ESA on the first ESA and ESRIC Space Resources Challenge back in 21-22, which was focused around prospecting. And this time you will hear all about the challenge. It's related to excavation and beneficiation.
Thank you very much. Is Bob here? I cannot see him. No, then Andy.
Yeah, hi everyone. Andy Gray, CEO of Exotopic. So I'll introduce the company later, so I won't do that now, but happy to support this challenge and ESA and LSA and Luxembourg Space Agency. And my background is sort of space engineering and consultancy.
All right, thank you. Mel?
Hello everyone, Happy New Year. I'm Melchiorre Conti, Space Resource Engineer in the Directorate of Human and Robotic Exploration. My background is in terrestrial application of chemical processing, and I support and guide Ryan in his activities for the Space Resources Challenge and many other things. And we are all very excited to give you a first rundown of what the challenge will be looking like and what will be expected from the participants. Thank you, Ryan.
Great. Let's move on to the agenda. So we'll have three parts for today. So the first one would be a brief presentation of the Space Resources Challenge itself, so the initiative, our ongoing campaign, and a detailed presentation on what the field test will look like, as well as the different evaluation criteria the participants will be evaluated on. And then we'll have a part on the prices and partners. So we'll have a presentation on the ESA price, on the beneficiation prize that will be awarded by Luxembourg, and as well, Andy will conclude this section by detailing the role of Exotopic as team partner. And then we'll have a 45 minutes Q&A before concluding this webinar and detailing the next steps. So Mel, I'll give you the floor to briefly mention the initiative and our ongoing call. Are you unmuted, Mel?
Apologies. So the Space Resources Challenge, what is the Space Resources Challenge? 3 years ago, the first Space Resources Challenge was launched, and it's been part and parcel of the evolution of space resources within the agency, because already in the 2019 strategy document on space resources, one of the key aspects that was identified for ISRU was to create these challenge-driven innovations. Why? Because it creates a community around the topic. He engages the various actors, it could be industry, could be research institution, and other people interested in evolving how we do things in exploration. And the idea is to, as is written on the slides, to foster innovation, encourage collaboration, but most importantly from the agency perspective is to accelerate the technology developments associated with the processes that are required to conduct space resources utilization on the celestial body we are aiming for, the Moon, Mars, and others, of course. And as important as everything else is to create and build and nurture the community of space resources, because it's a new topic mostly for the space people in Europe. Clearly, we do a lot of processing and chemical processing in our everyday life, but these needs to take a new step, an improvement of what we have today, so they can be done repeatedly, sustainably, in absence mostly of humans, and then bring back this learning to Earth, because that's where we get the most benefit, not just for the exploration, but the benefits that the exploration has on the community on Earth. So this was the spirit with which the first challenge was launched. So if you proceed to the next slide, please, Ryan. The first challenge, as I said, was launched in 2021, and at the beginning of 23, we started a very lengthy process to interact with the community, with yourselves, to understand from the community perspective, from industry, from academia, from all the innovators around Europe, which were the most challenging parts to do with the so-called space resources value chain that goes from the identification of the species that you want to use and extract resources from, to the point of utilization, the applications that are going to be using these products. So we came up with a very long and very strong roadmap, which aims not just to run the challenge for the sake of running challenges, but to increase the TRL, the technology readiness level of all the processes that are required by stage, because of course we have also to grow the visibility of the Space Resources Challenge, and we need to make these the important event in the space resources community when it comes to innovation and technology advancement, above and beyond all the other activities that go in ESRIC, at ESA, and in the member states. So the first one was on prospecting. The idea was to identify remotely and robotically where the resources could have been found. Then we will proceed to the challenge number 2, which is with excavation and beneficiation, which means excavate the regolith and provide the pilot plant with a suitable feedstock. Because the other important factor I forgot to mention is that all these challenges are revolving around the possibility of creating a pilot plant that will extract oxygen and metals for applications on the moon, but also on Mars and other celestial body. So the first challenge was the prospecting, then it would be the excavation and the beneficiation, so creating these optimal feedstock, which will be based on site sorting, and Kathryn surely will have more to add on the topic if requested, because we have to make sure that we process only the material that we can use optimally, given that there are so many restrictions in terms of mass, in terms of power, but also in terms of availability of resources from Earth. The next one will focus on the possibility to maintain and upgrade the pilot plants. And the last two will be on the, of this series, will be on the utilization of the products. It could be oxygen, it could be the regolith itself, it could be metals. And the plan is to slowly grow this event, for one day be able to have taken the technology readiness level up to the scales and all the way to TRL 8, at which point we will be able to launch a challenge on the moon, which will then give the technologies the TRL 9, which is the highest level. What's up for grab? Of course, there are two prizes, as we will explain. One is given by ESA under the form of a development contract, and the other one would be sponsored by ESRIC and the Luxembourg Space Agency. Whilst ESA will reward the overall winner, the ESRIC and LSA prize will focus on the team that provides with the best beneficiation system. Next slide. And as we all know, we launched these in October 2024, and we are currently running in the phase of the OSIP call, which is the first selection process. And here we are looking for informations that you can provide for your team, such as the description of the architecture that you envisage, a video presentation of yourselves, your solutions, but also looking at what kind of hardware is already existing and what experience do you already have in terms of field test. And of course, where the hardware is not available, we'll also accept simulation done for the hardware in CAD. Of course, we will also like to see what are the plans that you have to further develop your system until the field test, which will be done in Lunar in Germany, the analog facility where the field test will take place, which is a very large sandbox where you will be able to test your hardware. What kind of developments is needed for your hardware, for your software, the elements that compose your solution, and of course a short proposal on how you plan to carry out the feasibility study for the ESA contract. And optionally, of course, you have the possibility to also participate to the LSA ESRIC prize, and you will have to explain again in a short proposal how do you intend to use the money for the breadboarding activity that is underpinned by the prize. You can scan the QR code that you see on the screen. That will lead you directly to the submission page, and we all hope that we will see your applications in the system very soon.
Right. Thank you, Mel. So following the OSIP call as well, the selected teams for the field test in Lunar will be announced end of March. And now we're going to see more into details what teams will have to perform on the day of the field test and what you will have to demonstrate as well through the OSIP submission. So the idea is that teams will have 2.5 hours to collect, beneficiate, and deliver at least 5 kilograms of lunar regolith simulant using size sorting methods within a specific size range. And this size range is specifically tailored to optimize the molten salt electrolysis process, which is an oxygen extraction method. So this comes from our mission scenario, where we assume that operations using lunar resources to sustain long-term presence human on the moon's surface have started around the 2040s, and that astronauts partially rely on these resources, such as, for example, oxygen, and that they are typically staying on the moon's surface for periods up to 30 days to conduct scientific experiments, but also maintain the ISIU infrastructure. So the idea would be to sustain in oxygen, to provide enough feedstock to produce enough oxygen to sustain 8 astronauts for a 30 days mission. So to do so, the amount of oxygen is around 213 kilograms of oxygen, and considering the regolith is made up of 45% of oxygen, and within the scope of the challenge, of course, you will have to deliver 5 kilos of lunar regolith between 100 and 500 microns, which will produce roughly 2.25 kilograms of oxygen in the scope of this challenge. To avoid waste generation as well and to maximize the use of the regolith, you are asked as well to deliver all the excavated regolith into other size fractions. So there is a box with above 500 microns and below 100 microns, and the idea is that we want to show the versatility of this resource of the lunar regolith by having different applications, even though the focus of the challenge is the molten salt electrolysis process with the size range between 100 and 500 microns. Coarser particles could be, for example, used to build infrastructures on the moon, such as roads or landing pads. And below this size fraction could be used for 3D or additive manufacturing techniques. Below you have a high-level description of what the field test will look like. So Luna is about 700 square meter. filled with Lunar EAC1 simulant. So there will be a starting area assuming human activities around, where no excavation will be allowed. And everywhere outside this area, teams can excavate and perform beneficiation either at the excavation site or at the starting area, and deliver the beneficiated regolith in the compartments. Again, here the compartments can be around the starting area or at the excavation site. It's up to the teams, and they will be responsible to bring their own boxes and compartments as well. Teams will be evaluated based on 4 different criteria. The first one is size sorting beneficiation, which is 45% of the overall score, where the task is, as mentioned before, deliver 5 kilograms of beneficiated regolith within range, so between 100 and 500 microns. The second criteria is excavation, 30%, where you are asked to excavate a minimum of 15 kilograms of lunar simulant. The third one is mass and energy management, which is 15%. Here it's in the scenario where we are sending payloads to the moon, so they are restricted with mass and energy. So the total mass of the system should not exceed 60 kilograms, and the team should have an energy consumption of 300 watts-hour. And the last criteria, which is the dust containment, 10%, where teams will be evaluated on their impact on the lunar environment using the dust they generated as a reference. So now we'll go more into detail into each of these criterion and see how it will be evaluated. As mentioned before, the size sorting beneficiation criterion is we to beneficiate and deliver 5 kilos of beneficiated regolith between 100 and 500 microns with all the delivered mass in the box within range. If you manage to achieve this, you will get 100 points in this category. Teams will be evaluated based on the percentage of the beneficiated regolith within range in this box, and note that there will be no mass target in the other boxes, but as mentioned before, to avoid waste and maximize the use of the lunar regolith, we are asking you to minimize waste to deliver finer and coarser particles in the appropriate boxes. On the right-hand side, you can see a table with different scenario from the best case scenario to the worst case scenario. And we built this table based on some assumptions. So here you can see in blue the particle size distribution of EAC1, so the simulant that will be used in Luna. And we can see that around 50% of this particle size distribution is within the range we are targeting. And based on this assumption, we based our different scenarios on the right-hand side. There will be as well bonus and penalty points given. So 3 bonus points will be given for the box where the size of our target size for each additional kilograms in range. And for the 2 other boxes, you will get 3 bonus points for each kilogram in range if at least 75% of what's in the box is in range, and you have at least delivered half of what we are asking in the box 1. There will be again as well penalty points for each kilogram not recovered, which means, for example, if you excavate a total of 20 kilograms, we want 20 kilograms in the 3 different boxes. Otherwise, you will lose 3 points per kilo not recovered. The second criterion is the excavation one, where it's quite straightforward. You have to excavate 15 kilos of lunar simulant, and you will get 1 bonus point for each kilogram excavated. There will be weighing stations available around the field test, but teams are more than encouraged to also include their own system for measuring this data. And pay attention that each excavated kilogram needs to be recovered. So even if it's easy to get bonus points here, please note that it could be balanced with the beneficiation criterion, where you could get penalty points if you are not recovering your additional kilos. Mass and energy. The total mass should not exceed 60 kilos. So this will include all the assets of the team, except the box or compartments where the beneficiated regolith will be delivered. In parallel, the energy budget will be limited to 300 watts-hour, and this will include all the powered assets of the team. And this we will provide a measurement device per powered assets. So please include as well during your submission from phase 1 the number of powered assets. Here are the sensors that we have chosen. and ESA will check the right implementation of the sensor before a team is running. And in this category, exponential penalty and bonus points will be given depending if you are higher or below the limits we set. Finally, the last criterion, which is the dust one. Teams will be evaluated on their impact on the lunar environment using the dust they generate as reference. So assuming human activities on the starting area, the further you will go, the less you will be penalized. So here there will be some kind of trade-off. If you know your excavation system generates a lot of dust, then it would be more interesting to maximize the points in this category to go further. However, it may require more energy, so we are here asking teams to make some trade-off and decision-making with what is best to earn most of the points. So these are for the 4 evaluation criteria that will be used to evaluate the field test. And now I will give back the floor to Mel to mention the prices and start with the ESA price.
Thank you, Ryan. As we said, ESA will provide a contract for 500K for a feasibility study to take the solution, the winning solution of the challenge, and understand the feasibility of it to become a payload. These will happen after the selection of the OSIP campaign. Then the teams will be requested to subscribe to ESA Star, which is our administrative tool through which we can interact with consortiums once the ITT is launched. And a submission to the ITT, which is the vehicle through which we will administer this prize, will close in September 2025. Before all the documentation that we will provide will be part of the evaluation of these proposals. And the difference, the substantial difference between the regular or customary procurement approach of ESA is that here we will take into account the actual performance on the field test. So whilst in the regular procurement, usually you work with a proposal, which is essentially paperwork, here we want to improve our selection process to have a physical demonstration of the capabilities of the solutions provided, which will become part and parcel of the evaluation. So once the ITT is closed, then we will have the field test, of which only the teams that have been selected through the OSIP campaign will be allowed to participate. And roughly a month after, we will announce the winner, because we will have to evaluate the overall performance on the field test, which will have a substantial importance in the evaluation criteria, but also the skills and abilities of each individual team to be able to perform the development, the feasibility study that is object of this prize. So that would be how we will reward the winning solution, by creating a study that will take from a terrestrial mock-up or a terrestrial analog, transformed into a payload that could carry out these activities on the moon.
Right. Thank you very much. So now we'll move on to the beneficiation prize. Bob, are you here with us? Maybe you can briefly introduce yourself before we start. And Kathryn, yes. Maybe you could also give a few words on why beneficiation, etc. Bob?
Yes. So good afternoon, everyone. My name is Bob Lamboray from Luxembourg Space Agency, working on exploration and space resources. So in this case, also through the partnership we have with the European Space Agency in the field of space resources, we partner and sponsor a prize in the field of beneficiation. Why beneficiation? Beneficiation is an important step and also a core area of interest for ESRIC, that's based in Luxembourg. And to support the challenge, so we will sponsor an R&D contract similar to the ESA prize, but this time it will only focus on the beneficiation, performance on the beneficiation part, and an additional proposal for an beneficiation breadboard to be developed under the National Space Program, which is called Luximpulse and managed by ESA. So the process will be very similar to the ESA prize. So by September, there will be a call on the ESA platform where you need to submit a proposal that will be evaluated, and then taking into account the performance of the during the challenge in the area of beneficiation. We'll be selecting a winner and announce it by the end of November. There are two additional points to consider for this prize, is that as it's a nationally sponsored prize, half of the value must be spent in Luxembourg. So here we invite to get in contact with the Luxembourg space industry and partner with them to fulfill this 50%. And another question ahead, so but before it's asked, ESRIC being part of the organizing party or organization committee cannot be partner in the proposal. Thank you.
Thank you, Bob. Kathryn, you want to add something on why beneficiation in general?
Yes, I can add a couple of comments. So firstly, we at ESRIC are rather sad not to be part of this, obviously, but for obvious reason we cannot be part of the cannot be a partner in this challenge. One of the many interesting things about beneficiation is that no physical separation of particles is ever perfect. It's a really challenging technology. For those of us who've worked in the mineral processing sector terrestrially, where we do physical separation of particles, generally in water, most of the time, not often dry, it is not perfect. It is not possible to have a perfect separation physically of particles of different size and when you have a broad mineralogical composition. And so I think that's one of the aspects that makes this incredibly interesting, because now we have a strategic element. How do you, what technology do you target? How precise is it? And how many tons or grams will it let through? So this is one of the interesting aspects. It's an area that was overlooked in space resources in the lunar oxygen value chain for many years. There's been a lot more activity in this domain in the last few years, but I think we still have very little in the way of clear guidelines as to what we are designing our size separation, our size classification systems to. And so I think one of the exciting things about this challenge is it sets the target, and you must design your system to meet that target. So we are looking forward to seeing the range of solutions that are put forward. I think there are many ways that you can do that. There are many interesting, exciting ways that you can approach this challenge, but also there are many strategies that can be employed. And I think that's also a very exciting opportunity to explore the different ways that one can address this challenge and meet the targets.
Thank you very much, Kathryn. So now we'll move on to our last part of this webinar, which is the team partner. So Exotopic will be the team partner and will provide support to teams or people who wish to participate. So Andy, could you briefly introduce Exotopic and also describe your role as team partner?
Yeah, perfect. Will do, Ryan. So yeah, I'll try and be quick so we can get to the questions that I know you'd be interested in. What I'll do is I'll give a bit of an overview of Exotopic and what services we provide. But yeah, we supporting the challenge, so you can contact us, you can work with us. We are allowed to be involved in the challenge, and we basically will provide sort of in-kind services to support the delivery. So our company Exotopic, we focus on commercialization of science and tech, and particularly space. The sort of areas of our services sort of span from across kind of market, commercialization, business development, investment. So we work with quite a wide range of investors as well, thinking about future funding, thinking about different types of applications and markets that you might apply the technology for, thinking about particularly the kind of how you might sustain the development of your solution, or complement the funding that you might receive through this challenge with other sources of finance as well, but also access to test facilities and specialist expertise in space, but also particularly to sort of lunar and space exploration activity as well. Just go on to the next slide, Ryan. So in terms of services, so we run accelerators, etc. We work a lot with universities, people who are looking to spin out technologies. We have a strong understanding of how to sort of commercialize technology long term. We work in scale up. We do a lot of R&D and TRL raising. We understand about technology development, road mapping, particularly when it comes to space technologies. So anyone who is interested in getting involved in the challenge, who is not necessarily has space as a sort of core knowledge domain, then we can definitely support with understanding more about the space environment, etc., and some of the things you might want to think about when it comes to developing space technology. Also, sort of training and other kind of skill services. So we do have access to various experts as well, who can support with understanding more about some of the specifics about the environment, for example, and some of the how the environment may impact some of the design choices you might want to make or consider, not necessarily in your prototype, but maybe to consider for your sort of long-term development roadmap. Next slide, Ryan. So just in terms of like generally the things that we can support with, so as I've kind of explained, we provide kind of consulting services and can support with sort of proposal writing and planning and development, but we can also support with hands-on activities. We do sort of operate perform satellite missions, so we're doing technology in orbit demonstration missions. We have some test facilities that we build and operate in the UK at the moment, which around different types of like propulsion systems, etc., which might not be relevant to this, but we also have access to other types of facilities that we can support you with. So, for example, at the moment, there's a facility near one of our offices in Glasgow, which is a ESA facility that supports with dirty vacuum testing in relation to sort of lunar and Martian missions. So there's various kind of facilities that you might want to consider for the long-term development, and we can support with access to those as well as supporting with like prototype development. Next slide, please, Ryan. And yeah, I just wanted to finish with some of the work we've been doing recently on challenge prizes. So we've been working on the Lunar Challenge, which is a UK and Canadian challenge prize around water purification. So turning dirty ice into clean water on the moon for utilization, not necessarily as a drinking source, but for fuel, etc. And there we've been, Exotopic provides sort of a range of support to people. So supporting with around kind of like considering the IP of technologies that are being developed, considering testing plans, testing processes, commercialization investment, but also particularly linking up with terrestrial applications as well. So maybe considering where there may be a terrestrial use case for the technology that's being developed. We have quite strong networks outside of space and working a lot with industry. We've just opened an office in Australia, actually, and quite strong connections with mining, which might be relevant for these types of technologies. So we'd be very keen to look at how, particularly with these kind of things that commercialize longer term, thinking about how we can support with nearer term commercialization through some maybe of the relevant aspects of the technologies developed. Yeah, so I think I'll probably finish there. So we do have, like I say, access to other forms of finance as well to support people. We have VC and angel networks for people who are looking to raise funding, as well as sort of grants and debt finance. So yeah, please do sort of reach out to us. We're happy to support. Like I say, we're supporting the program, so it's sort of free to work with us and an opportunity that we hope you take advantage of. But yeah, looking forward to working with people on the challenge. Thanks, Ryan.
Thank you, Andy. So here you have a point of contact here on the slide, and as well on the rulebook, you can find the point of contact from which you can reach out. The rulebook is attached to our OSIP call. So now we'll move on to the Q&A session. So I'll go back to chat and I'll go through the different questions. All right. So we have a question from Mehmed, who is asking if there are any requirements for the rover or excavation test from the perspective of autonomy. Mel, I don't know if you want to take this one.
Yes, we are not including any requirements on autonomy because the risk would be that the autonomy part, which is rather complex, could overtake the actual hardware development, which at this moment in time, from the beneficiation point of view, we are much more interested. So the rover might be autonomous, it's not a requirement. We envisage that the rovers will be guided remotely using the visual offered by the mobility platform, and we might complement with further imaging as part of the setup in Lunar.
We have a question regarding are other oxygen extraction processes acceptable for this? Description request molten salt electrolysis for the extraction process. Is it a hard requirement, or will you allow expectations? So in our scenario, yeah, we tailored it to the molten salt electrolysis. So I think, I'm not sure, Mel, if we are open to other.
Here we need to consider that we are working extensively in establishing some capacity in producing oxygen and metals using regolith and using in particular molten salt electrolysis. Other processes are not considered as part of this challenge for the time being, and this is why we have selected the particle size distribution that we have selected. For other processes, other particle sizes will make more sense. So it's pretty specific, yes.
All right. Then we have a question regarding the recording. So yeah, the recording will be available in our social media channel following the meeting. Then we have a question from Luis, who is asking if there is any topography about Lunar. So this would be a question more for related to EAC people. All we know is that it's 700 square meters. There will be area with crater, but any information I think regarding the shape of Lunar and the topography will be provided further for the people qualified for the field test. And of course, as we mentioned before, there will be the particle size distribution of Lunar according to this curve. So there will be area maybe with coarser or finer particles. And we have a question then: how many teams will be present at once on the field test. So the field test will last for 5 days, and we plan running 2 teams a day. So roughly around 10 teams in total will be here for the field test.
And if they will be all individually slotted on the field, there will not be overlapping of teams.
Then we have a question from Kim. If the project is awarded under development contract from ESA, what happened to any IP? So Mel, I think can go on this one.
The IP will be handled as part of the contract in the ITT, and the provisions are the one of the normal contracts in which ESA doesn't really take ownership of the inventor's IP. The IP will remain with the solution provider, provided that any IP that is generated as part of the contract would be available for use to ESA.
We do have a question regarding if prototype of original model can be submitted for the first round. So yes, definitely you can submit anything where you are at the moment. So it can be CAD models, prototypes already. So definitely. Then there's specifications. Are there any specifications on the length of the videos for phase 1, less than 10 minutes or longer? As long as it contains all the information that are requested in the video, I mean, we are not keen on having a time limit, and I'm not sure there is a limit actually on the OSIP platform, so you can on size limit regarding what you are uploading, so you can have videos up to the length you want. Is there requirements to monitor gas and particle levels while excavation is ongoing? No?
Gas, I am not sure where it's coming from. I don't think we will be able to simulate any condensed gas in the Lunar regolith. The excavation will be monitored in terms of the dust emissions. So definitely we'll be looking at how much dust is being generated as part of the challenge, as per the rules. I hope it makes sense. Otherwise, we can expand.
Then we have a question regarding the field test itself. So can the system be accessed during the challenge, equipment repair maintenance within the field test durations? So yes, this is something we plan. So the idea would be to fully have the system remote control with only the visibility of what your system sees. However, if there is an issue, you will be able to access once on the field test to repair. But this rule still needs to be extended and more detailed. But yeah, there will be the possibility to repair and maintain briefly during the field test. Are you allowed to change the system designed after the submission? I would say yes, if you are already if it's not a major change in your system. If you mention you will apply this change already in the short proposal, you would be able, I would say, to change it. Yeah. Please note as well.
Probably depends on which submission, because for the OSIP submission there is no problem. However, of course, once we start evaluating your system during after the OSIP selection, we will be looking at the proposal on paper, but also on the hardware on the field. So if you have been allowed to go through on a certain design, there will be a strong requirement of understanding why the system has been completely changed. For smaller modification, that can be accepted. Sorry, Brian, go.
All right. No worries. We have then a question from Manuel. How is excavated regolith weighted? Will the measurement be based on sensors used by participants, or will the regolith be weighted before beneficiation? If so, will the measurement time be included in the field test time limit? So regarding the excavation mass you have to collect, so there will be weighing platform like balance a bit around the field test. So knowing your mass of the system beforehand, we will measure as well and keep track of how much you excavate in time. So that's why we are encouraging you as well to include some systems to monitor this data yourself. And yes, it will be also the measurement time for to weigh the excavation will be directly included in the field test limit. Will the teams have access to the same Lunar regolith simulant as the ones used at Lunar or any other kind of simulant during the development? On this, I'm unsure if I'm unsure if you can purchase EAC1 simulant on your own.
Well, yeah, the simulant will be EAC1, and we can support by discussing with the EAC and the curation facility whether samples can be handled to participants. But these we will have to take away and discuss internally to have a full response. Of course, we will give a full response when we publish the outcome of this webinar.
Yeah. Right. Then we have a question regarding the level of technical details necessary during the challenge submission phase. So I guess it's the OSIP phase, so the first phase. Mel, you want to give an answer on this?
So at this moment in time, we are looking for a light proposal, not nuts and bolts sort of proposal. We want to understand how you approach the problem, what is the hardware that you already have. Of course, if you have more hardware at your disposal, that shows that you are closer to implement the test field than other competitors. And of course, if you are realizing CAD, then you will need some form of technical details that will allow you to create that model. So the technical detail is important because that's what we are judging you on, not just the video. The video is an introduction, is an ability to see what you're capable of, what you have done already, and what you are planning to do in the future. But we can't do that without a level of technical details behind it.
Great.
I think there was one that.
Yeah.
No, sorry,
If
never mind.
If there is any questions
was...
I miss, do not hesitate to jump in.
I think there is one from Luis Torres Juarez. I hope I said the name correct. Also mission based around a rover mobile machines, or can proposal for semi-permanent installation be provided? You want to take this one, Brian?
No, go for it.
We don't have a preference of how the system will be handled. It could be one machine that does everything. It could be a rover plus other platforms. It doesn't matter. The idea is that we will be looking at who can achieve the separation that we want with the mass and power that we have given. And when this has been done, then we will check who's done best in terms of performance. So the architecture is open to any interpretation possible.
Then we have a question regarding the eligibility of participating. So can the team have a non-European university or research organization that is currently working on a similar project? So all participants need to be within E3P, so your exploration program countries, which are basically the countries listed below on this slide. So any entities from this among these countries can participate to the challenge. After, I'm not sure if the main submitter is within the countries, as it's mentioned in the question. The team have a non-European or research organization. I don't know if it's a consortium of multiple research organizations, but as long as I think as the main submitters is from the one of these countries listed below, it should be fine. We have a question from Luca regarding the dust movement. Would there be an actual sensor measuring for the particles suspended in the air? Yes, so I think that I forgot to mention during the presentation is that the dust criterion is still under definition. So we are thinking of having different ways and different type of sensors, so active and passive sensors, to keep track of the evolution of the dust while the team are performing. And more information will come later on this criteria. Then we have a question regarding the rulebook. So the rulebook mentions an upper limit on particle size in box 2 of 1,000 microns. And the slide in the webinar only mentioned above. It's because in the rulebook we mentioned for box 2, between 100 and 1,000 microns is the size. So Lunar doesn't have particles bigger than 1 millimeter, basically. But yeah, anything above 500 microns encompasses as well the 1,000 microns. Okay, do we have any other questions? If some of our answers were unclear, maybe if you can re-ask the questions. So the rulebook suggests that the size percentage distribution may or will be slightly different than the one provided. How different is it going to be? So in theory, we have this particle size distribution all across Lunar, but there, as mentioned before, there may be areas where you can find finer or coarser particles. It will not be the same particle size distribution all across Lunar. So this is the difference, mainly. Then we have a question regarding the starting area. How large is the starting area? This area still needs to be defined, as well as the different areas we mentioned here with the dust. So this information will be given further. Then we have a question from Suleiman. Is the lunar test yard filled with loose simulant? Are there randomly placed areas of compacted powders? And how deep can we excavate? Mel?
So the lunar facility will be filled with loose regolith in a way that resemble as much as possible the environment on the moon, because that's why it's been created, to test hardware solutions and as a training center for astronauts. I wouldn't say that areas will be randomly compacted. However, you have to think the 700 meters square of regolith with variable depth. I think the deepest part is up to 10 meters, and the shallower part is about 1.5 meters or something like that. I can't really remember. It would be impossible to keep the level of compactness homogeneous throughout. So it would be really as a test field that you will find with certain elements of randomicity included. However, we will double check the exact depth of excavation that you can reach. However, is also prepared to accept deep drilling. So I would expect that will be more than enough for deep drilling, but we will add information post this event.
Another question regarding the starting area. Is it going to be regolith as well or concrete? So I think we'll try to simulate what would look like a human kind of base camp around it. So I think we've kind of compacted regolith or maybe roads. But yeah, there will be for sure dust as well. What method are you going to use to check the size distribution of the beneficiated sediment? So yeah, that's a good question. I forgot to mention as well in the presentation. So as mentioned, we will evaluate the percentage of the beneficiated regolith within range. So basically, we'll take a few samples on each box and put them into a masticizer, and we'll make the average and see, and it will give us the percentage that is within range, basically. And yeah, again, we have a question on autonomy. So no autonomy is required for any part of the tasks. No.
It's not required, but could be implemented if the team decides to, but it's not a requirement.
Are there any constraints on the shape or size of the collection bins for beneficiated regolith? So as mentioned, you are free to bring your own, so it can have the shape as you want. And as mentioned before, it will not count in the mass budget. So yeah, you can decide on whatever you want to bring. But of course, it must be accessible for us to take the samples for the masticizer, to put in the masticizer, and as well to weigh the different boxes. All right. I don't know if I missed some question.
There is one from Luke again. So a rover would always have to deal with a certain slopes, or is it already known that it could be avoided to go down in a crater of some sorts?
You want to take this one?
The field test will be defined when we approach the actual date of the field test, and it will be made known to the participants that are selected to go to the field test, and there will be slopes. We have not defined yet what those slopes are, but you would be expected to navigate the landscape that you will be faced with.
Then we have a question regarding teleoperation. So direct teleoperation is allowed, or any delays in communication introduced. So there will be no delay. So you will see live what your solution sees. So yeah, we have again a question on the maximum mass required for the system. So the total mass of your system should be no more than 60 kilograms, and this will include all the assets except the boxes / containers for the beneficiated regolith. How is the light conditions at the Lunar test yard? On this, I'm unsure if the realistic lighting conditions will be available on time. I think so. This is something we will need to double check. Can a team deploy multiple systems as long as the total mass is 60 kilos? Yes, you can. But consider as well that you have the energy budget that you have to take into account. Make sure you do not exceed this limit by multiplying the number of rovers. Right. Okay, I'm not sure we have any more questions. I will maybe wait just a few minutes, 1 minute, to see if we get new questions. We got one. Those beneficiated materials needs to be brought back to the starting area or can be left at the excavation site. So the idea would be to have so you are free to choose whenever you want to beneficiate and deliver your feedstock, considering the human activities around the starting area and the hypothetical pilot plant, where you will have to deliver your regolith, your beneficiated regolith, and put it in the pilot plant. It would be preferable to have it delivered around the starting area, but again, you are completely free to choose where you want to excavate, beneficiate, and deliver your beneficiated regolith.
Well, I would say that the utilization happens in the stacking area.
Yep.
So,
regarding the beneficiation price, does the partner from Luxembourg already need to be part of the team at the time of the submission, or can the partnership created after the outcome of the challenge? I'm not sure to understand this one. So whenever you submit to our OSIP campaign, you will be able to select a box if you want to participate to the beneficiation price, and here you will have to indicate to add a short proposal on this price. And then if you are selected to compete for the field test, you will have to submit a full proposal similar to the ESA price linked to the activities of this price. Not sure if Paul, I answered your question.
Maybe I can try to add a few words here. I think for us it's important to have this Luxembourg partner in. Now the final partner has to be known when the project starts now. So I think in your proposal you need to have a partner. If afterwards there's a slight change, I think that will then be done in a negotiation or in the formal proposal later.
Thanks. Any other questions? I see we have a raised hand, but unfortunately we cannot give access to microphones to the attendees. So please write your question in the chat. Waiting for the last question. All right. If not, then we can move on to our conclusion. So before we conclude, any final words, Mel, Kathryn, Andy, Bob?
Please keep reaching out to us through the OSIP campaign for questions and for any comments that you have. And thank you for participating in a high number, more than we expected, that's for sure, to this webinar.
So yeah, what's next? So now, as mentioned before, you will have until the 20th of February to submit your submission through our OSIP platform. You have the QR code here to submit. And by end of March, we will select the teams that will go and compete to Lunar. Phase 3 and 4 here are the procurement approach for the different prices. And the field test will happen in Lunar in October 2025, and the winners will be announced in November 2025. If you have any more questions, feel free to send an email to the email address here on the slide. And if there are no any other questions or comments, thank you all for attending this webinar. Thank you all for your time. Thank you, Kathryn, Andy, and Bob. And wishing you a nice end of the day, everyone. Thank you.
Thank you, Ryan.